Hi everyone. I am here to talk about something interesting with respect to programming. Whenever I meet freshers or people who are new to computer science and ask them to write a function and demonstrate how do they test that function, I'll be usually will be shown something like this. It's C programming language. A function written in C language. The function is prime, which is used to check whether the passed in number is a prime or not. It's a very simple problem, interesting problem actually. Let's not worry about how it is implemented, the logic of it. But what catches our attention is these lines of code which is used to test this function. So first let's see it in practice. Let's go ahead and compile it. Main.c. So C is a compiled language, so you will get an executable. Let's execute that. So of course it is going to prompt you. This is the classical way of testing programs. So we have also done this. Let's go ahead and enter some. Okay, 10 is not a prime. Let's try again. Let's enter 11. 11 is a prime number. We all know that. So 12 is not a prime. What about 15? 15 is not a prime number. Seems like this program is working, right? Good. So let's try something like 59. 50 is a prime. Okay. 100. What about 100? Let's try that. 100 is not prime. And let's try some small numbers. Enter 1. 1 is prime. Is 1 a prime number? What about 0? Let's try that. 0 is prime. Let's enter 2. 2 is prime. Is 2 a prime number? I don't know. 4. 4 is prime. Definitely we know that 4 is not a prime number, right? But the program is saying it is a prime number. So, in conclusion, this approach has some disadvantages. It requires very careful attention from the user, that he has to look at those prompts and enter proper inputs and also observe what the output says, right? Because the program is going to display this in console, some result of your inputs, right? So after using your inputs and running that function, some output will be there, and it is actually writing that back to the screen, and users have to carefully look at that and deduce what is the behavior of the function, right? Also, with this approach, we can cheat as well, right? Let's say our instructor is standing behind us and we are supposed to demonstrate that the function that we have written is really working. So what we can do is we can cheat, isn't it? We run it a number of times, but only supply those inputs for which the program always works, right? Yeah, this approach will not ensure that the function is really taking care of all boundary cases. It works for range of inputs, right? And it is really robust. This approach cannot achieve that. So then what else we can do? Of course, we have seen that this is quite repetitive and boring for humans. And you know what? With such boring activities, which are difficult for humans, they're very easy for computers. Computers will never get bored, right? So, can we automate this process? Instead of us entering inputs and observing what outputs, can computer itself help us even testing this function? If that can do it, that's wonderful. How we can do that is something that we will explore in our next video. Stay tuned. Thank you.